It seems nobody has joined. So, okay, we'll wait for 5 to 10 minutes for people to join. Then we'll start.
Hello, sir. Good evening.
I'm momentarily pausing the recording,
Yes, sir.
so I'll switch on the recording. Just wait a minute before. Just wait. I'll start after 1 minute. One single question. So I'll start within 1 or 2 minutes. I'll start. Okay, so we can start. Jitrani has left, so we will just go through whatever slide we have prepared based on that. Or maybe we can wait for few minutes for her to join again, or otherwise we'll just start as it is. Okay, we can prepare one more question, I guess. Then we can start. As today nobody has joined, so we will not take any break. We'll just continue in a rushed manner. So yeah, let's add one more question before starting. So as nobody has joined, we'll start after 1 minute and we'll just the recording is on. Yeah, it is on. So we'll just go through the slides. We'll record it and we'll upload it, and people will access that. The raw file will be uploaded, and we'll just quickly go through the question answers. We'll not wait in between. Okay, so it is 1st of September 2024. My name is Shudham Sadhukan. I'm a teaching assistant under PMRF category. I'm a PhD scholar of IIT Bombay, and I'm a teaching assistant of the live weekly interactive session. Welcome to the 6th week of NPTEL course code AR18. The course title is Urban Utilities Planning, Water Supply, Sanitation and Drainage. It is instructed by Dr. Debapratim Pandit, who is a professor of IIT Kharagpur at the Department of Architecture and Regional Planning. So where are we? We're at the 6th week. So after this session, 50% of the entire sessions will be covered. Okay, so let's start. Today's first question is, we have to identify the factors that are those are important in deciding the size of the pumps. Option A is flow needed at the point of connection to the distribution system. Option B is fuel consumed, and option C is discharge head. Okay, so the explanation is something like this. Pump sizes are determined as per the discharge head and flow needed at the point of connection. So both option A and C are the correct answers. Fuel consumed is not a correct answer, because fuel consumed is something that is related to the motor. Generally, motors are electrically driven or driven by fuel oils like diesel or petrol, like that. But the major two things, those are mentioned in the specs of the pump, that is the specification details of the pump, that is the flow rate, mostly in meter cube per hours, and head, discharge heads, which is nothing but the pressure expressed in terms of meters. So if we see the, just see the Bernoulli's equation, which is P by rho g v square by 2g plus z equals to constant, there the term z is the head, or the entire thing is head when pressure is divided by the product of density and gravity, that is the gravitational constant, and in this way pressure is converted into discharge head. So these are the two major things which are mentioned in the any specification of the pumps. Option A and C are the correct answers, and B is not the correct. Okay, so now next, there is a problem where we have to consider a city with a population of 5 lakhs having daily water consumption at 180 liters per capita per day, and the maximum is, that is the maximum water consumption is 1.8 times of the average consumption. Flow velocity is given as 1.4 meter per second. Based on this data, we have to find the size of the supply conduits leading to the service area. So the data given are, flow velocity V is given as 1.4 meter per second. Average daily demand is given as 5 lakhs into 180 liters per day, which is nothing but 90 million liters per day. Now maximum daily demand is nothing but 1.8 times of the average consumption. So average daily demand is calculated with the help of multiplying the population with the per capita daily demand. If we multiply these two, it becomes the daily demand of the entire population. Now, this is the average daily demand. If we multiply it with the factor 1.8 that is given in the question, then we will get the maximum daily demand as 162 million liters per day, or MLD. Okay, so the solution is something like this. First, we have to calculate the maximum design capacity, or Q, based on the above data. So it is nothing but 162 into 10 to the power 6, as million means 10 to the power 6. We have discussed multiple times in earlier classes that million means 10 to the power 6. So 162 into 10 to the power 6 divided by 1000 into 24 into 3600. Why this factor came? So first we have to convert liters into meter cube. 1 meter cube equals to 1000 liters. So that's why we are dividing with 1000. Then we are taking 1 day means how many seconds. So 1 day means first 24 hours, and 1 hour means 3600 seconds. So that means 1 day means 24 into 3600 seconds. To convert this maximum daily demand, which is million liters per day, into meter cube per second unit, we are dividing it with this factor, that is 24,000 into 3600. After simplification, it gives 1.875 meter cube per second. Then cross sectional area is nothing but pi d squared by 4, where d is nothing but the diameter of the conduit, supply conduits. Okay, now cross sectional area can also be represented as q by v, where q is the design capacity in meter cube per second, v is the velocity in meter per second. So meter cube per second, meter per second, second gets cancelled out. Meter cube per meter gives you meter square, that is the cross sectional area, unit of the cross sectional area. So it can be expressed as both ways. Now the value of q we know, we just have calculated 1.875, we just put, and v, that is nothing but the flow velocity, it is given in the question as 1.4 meter per second. That is the data given, we just put from there to here. So q by v gives you the cross sectional area, which is nothing but 1.875 by 1.4 equals to 1.34 meters square. Lastly, the supply conduit size, which is nothing but the diameter of the supply conduit, expressed as d in meters unit, is given as 2 into root over a by pi. So pi d squared by 4 equals to a. So pi d squared equals to 4a, d squared equals to 4a by pi, and d equals to root over 4a by pi, which is nothing but 2 into root over a by pi. Now the value of a we know already. We have calculated from the value of q and v. From the previous, we just put the value of a and divide it with pi. So 1.34 divided by pi gives us 0.42631. Okay. Now 2 into root over 0.42631 gives us 1.306 meter. So this is the conduit size, which is nothing but the diameter of the conduit in meters. Okay. So our next MCQ is Previously, the 1.306 meter was the answer, which is the whenever the size is being asked, then size of the any supply conduit or pipe means the diameter of the pipe. Now the next MCQ is the lift against which the pump should work is taken as the dash of suction lift, discharge lift, and head loss. We have to fill in the blanks. So option A is sum, option B is difference, option C is average, option D is product. The lift against which these pumps should work is taken as the what of suction lift, discharge lift, and head loss. So the answer is the sum. The pump should work against the summation of the suction lift, discharge lift, and the head loss. The head loss is nothing but the pressure drop that occurs when the fluid flows through the pipeline due to the friction of the fluid layers with the inner wall of the pipe, and whenever the fluid gets collided in the vents, then also head loss occurs. Discharge lift and suction lifts are the lifts in the discharge side and suction side respectively. So pump should work against all of them in order to lift the water or fluid. Now next MCQ or multiple choice question is, in which of the following methods for detecting leakage inside of pipelines vegetation growth can act as an indicator? So option A is water meter, option B is sounding rods, option C is pressure gas, and option D is direct observations. So the explanation is visible wet areas and or unexpected vegetation growths are detected through direct observations. Okay. So the answer is the direct observations. Now we will have to identify the correct ones from the following statements regarding the setting of pumps in the water supply networks. Option A is butterfly valves are used for isolating the pumps in the suction side. Option B is check gate valves are installed in the discharge sides. Option C is pressure relief valves are used in the discharge sides for flow controls, pressure regulations, and to protect from surge pressures. Option D is vacuum relief valves are used on the suction sides for the vertical turbine pumps. We have to identify the correct ones from the following statements regarding the setting of pumps in the water supply networks. Okay, so the explanation is sluice gates or gate valves are used for the isolation of pumps in the suction lines. Butterfly valves are not used in the suction sites. air release and or vacuum relief valves are used on the discharge sides for the vertical turbine pumps. So option B and C are the correct answers. Check gate valves are installed in the discharge sides. It is not installed in the suction sides, and pressure relief valves are used in the discharge sides for flow controls, pressure regulations, and surge protections. Whereas the vacuum relief valves are not used in the suction sides, it is used in the discharge sides, and butterfly valves are not used in the suction side, it is used in the discharge side. Okay, so now next is a problem. A water supply scheme is to be designed for a population of 5 lakhs. The storage reservoir is located at a distance of 13 kilometers away from the city. Consider head loss from the source as 15 meter. The average demand is 250 liters per capita per day. Assume that the maximum demand is 1.6 times of the average. Estimate the size of the supply main using the modified Hagen-Williams formula. For metal pipes, consider CR equals to 1. Okay, as nobody is there, we will proceed with the solution. So the details explanation is modified Hagen-Williams formula is V equals to Q by A. Again the thing, velocity equals to the volumetric flow rate divided by the cross-sectional area of the pipe, which is nothing but equals to 143 into 534 into CR into R to the power 0.6575 into S to the power 0.5525. This is the modified Hagen-Williams formula, where velocity is the function of the CR, which is nothing but a coefficient. In the question, it is given as 1. This is a constant into R into S. S is the slope of the energy line, which is nothing but the head loss per unit length of the pipe. Now, as I told, slope of the energy line S equals to head loss divided by pipe length equals to 15 meter by 13,000 meter. So in the question, it is given as head loss is 15 meter and pipe length is given as 13 kilometer because the water needs to be supplied at a location which is 13 kilometer away from the pumping source. So that means 13 kilometer means 13,000 meter. And to calculate the S, we are dividing the head loss with the 13,000 meter. Meter gets cancelled out. So S is a unitless number. Now the average daily demand is nothing but 5 lakhs into 250 liters per day. So the average per capita demand was given as 250 and we are multiplying it with the total population, which is nothing but 5 lakhs, and that gives me 125 million liters per day. The maximum daily demand in the question is given as 1.6 times of the average daily demand. That's why it is 1.6 into 125 million liters per day, which is equals to 200 million liters per day. Now maximum design capacity Q can be calculated in this way. Maximum daily demand 200 million liters means 200 into 10 6 liters divided by 1000, this many meter cube, whole divided by 24 into 3600, this many seconds per day. That means 2.315 meter cube per second. Now cross-sectional area A is given as pi d square by 4, which is nothing but equals to q by v. So these are two expressions of the A. One is the function of diameter, another one is the function of volumetric flow rate and the velocity, which is meter cube per second and meter per second. And after simplification, we get v equals to, so v comes at the left hand side and 4 goes into the right hand side. So v into pi d square by 4 equals to 4q, which is nothing but v equals to 4q by pi d square. Here we are expressing the v in terms of the d. Now v and q, these things must be known. So not known. So v is a term at the Hagen-Williams formula. So that's why we are calculating like this way. Now we will replace the v like this way. So after substituting the values in the equation, we get something like this. 4 into 2.315 by pi d squared equals to this terminology. So which is 143.534 into CR in the question given as 1, R to the power 0.6575 into 15 divided by 30,000, which is we have just calculated the value of S, whole to the power 0.5525. Now here we have to see that the value of Q, this we have calculated as 2.315 meter cube per second. So Q is nothing but the maximum design capacity we have put. Now in the left hand side there is D, because we have to ultimately calculate the size of the particle pipe. So that's why we are converting the entire equation in terms of D. And another term that we have not yet discussed, that is the R. It is nothing but the hydraulic radius. For circular pipes, the hydraulic radius is defined as pi d square by 4 divided by pi into d. This pi gets cancelled out, d gets cancelled out, another d is left, so it is d by 4. Where the assumption is the water is present in the pipe under full flow condition. That is, the entire surface area inside the pipe is weighted. No free surface is present. Okay. So that means there is the fluid is not like up to this level, it is not like that. It is completely full inside throughout the cross section area of the pipe. If this condition persists, then the hydraulic radius becomes the weighted area divided by the weighted perimeter. So this pi d square by 4, it is nothing but the entire cross sectional area that is weighted inside the conduit or pipe. And pi d means 2 pi r. It is the perimeter. So weighted area by weighted perimeter, where d is essentially the inside diameter of the pipe. Weighted area by weighted perimeter gives you the hydraulic radius. This is by definition. So hydraulic radius is nothing but the inner diameter by 4. That means inner diameter equals to 4 into hydraulic radius, which is in our case. So R is the hydraulic radius. We have put it as D by 4. Okay. Where D is the inner diameter. Now both the left hand side and right hand side came in terms of D. After simplification, which gives us 4 into 2.315 gives us 9.26. This divided by 4 to the power 0.675 comes from right hand side to left hand side and becomes into 4 to the power 0.6575 whole divided by pi, and this d square goes at the right hand side, and after simplifying it with d to the power 0.6525, this 2 plus 0.6525 gives you d to the power 2.6575. Now the rest things remains the same. This one is 1 into 143.534 gives you 143.34, and this term remains the same, 15 by 30,000, 0.5525. In this way, now we arrive at the solution. The size and diameter of the supply main, which is expressed as this d or diameter of the pipe in meters, it gives us the entire this 9.26 into 4 to the power this divided by pi whole divided by this constant and this constant gives us 2.145478 equals to d to the power 2.6575. So d equals to this entire constant whole to the power 1 by 2.6575 equals to 4 by 3 meter, which is approximately equals to 1.333 meters. Now in the question, it may be given as let's say 1 meter, 1.5 meter, then 2 meter, 3 meter. The options may be given like this way. We have to choose the nearest option because this kind of diameters are not available exactly the way we want. So we have to uh, take the nearest higher value from the available options. So if in the options there is 1.5 meter, it becomes our desired diameter or size of the pipe. Now, the next problem that we are going to solve, it was a assignment problem, and one of the students raised this query in one of the in the discussion forum that the answer of the question is wrong. So that's why we are discussing it in this class. Basically, what has happened, the answer was correct, but it is unfortunately given as in percentage value, which is not the case. So we have to ultimately in this question we have to calculate the hydraulic gradient, that is the S value, which is nothing but the slope of the energy line, right? In the Hagens-Williams formula, but it is should not be given as the percentage. So the student has correctly identified the answer. Those are provided in the answer sheet is wrong, and either all will be given marks for that, or only or no one will be awarded marks for that. So to clarify the confusions, let's move on to solving the problem. So for a city with population of 5 lakhs, it is similar to the previous problem, and water consumption rate is different. It is given here as 135 liters per capita per day. Water needs to be supplied. Now flow velocity of water inside of pipes is 1.5 meter per second. Coefficient of hydraulic capacity, which is nothing but CH, or which was CR in our previous question, is 130. Maximum daily demand is 1.8 times of the average daily demand, which was 1.6 times in our previous question. Based on the above data, we have to determine the value of S, which is nothing but the this S in the Hagen-Williams formula. It is the pressure drop per unit length of the pipe, and the previous problem was based on the modified Hagen's formula. This problem is based on the Hagen-Williams formula, which is given in the question as V equals to 0.85 into CH into R to the power 0.63 into S to the power 0.54. So welcome Shureka. This problem we are just solving from the assignment problem, and one student raised a concern in the discussion forum that the answers those were given were wrong. So if you have solved the last week's assignment, then you will able to follow what we are discussing here. Okay. and the rest of the things which we discussed earlier in today's class, that you can see from the uploaded slides that will be available after the class. Okay. Now the solution goes something like this. So have you solved the problem in the assignment? Did you face any problem like another student raised in the discussion forum?
No, sir.
Oh, you didn't face the problem. Okay, so we'll discuss the answer. So the explanation goes like this. Hazen-Williams formula, as it is given in the question, it is V equals to 0.85 into CH into R to the power 0.63 into H to the power 0.54. It is given in the question. Now, the velocity is given in the question also as 1.5 meter per second, which can be expressed by volumetric flow rate divided by the cross-sectional area of the pipe. Right? So it is meter cube per second. It is meter per second gives you, sorry, it is meter square gives you the meter per second. Average daily demand is the total population into the per capita demand. That means 5 lakhs into 135 liters per day. That gives us 67.5 million liters per day. Welcome, Bubu Mukherjee. So this problem we are solving from the assignment problem, because it was raised in the discussion forum that there is something wrong with the answers those are provided, and the rest of the problems which we discussed earlier in this class, that will be available from the slides after the class. Okay, there you can access that. If you are not able to access, you just raise it in the next class, or you can raise it in the discussion forum. Okay, so now maximum daily demand in the question given as 1.8 times of the average daily demand, which is nothing but 67.5 million liters per day. That gives me 121.5 million liters per day. Now maximum design capacity Q is based on the maximum daily demand, where we have to convert the million liters per day unit into meter cube per second. So 121.5 million means 121.5 into 10 to the power 6 divided by 1000 gives us meter cube from liters, because 1 meter cube equals to 1000 liters. Now from day to second, in order to convert, we are multiplying with this factor, the denominator. 1 day means 24 hours and 1 hours means 3600 seconds, which gives us ultimately after simplification 1.41 meter cube per second. So now cross sectional area A equals to pi d squared by 4 for a circular pipe, which is also Q by V. Q we have calculated volumetric flow rate 1.41. V it is given in the question 1.5 meter per second. We just put those two values, and in this way the value of A comes out to be 0.9375 meters square, 0.94 meters square. Now there is a concept of hydraulic radius. I don't know whether you to know this or not. So hydraulic radius means uh, if you don't know, you can ask. So still I will discuss that hydraulic radius means the weighted area by weighted perimeter. So if the fluid is flowing through this conduit and it is weighting the inside surface completely, that means no free surface is left. It is called as the full flow condition. Under this condition, the hydraulic radius will be the weighted area by weighted perimeter. So this D is the inner diameter of the pipe. So the cross sectional area is pi d squared by 4 and the perimeter is 2 pi r, that means pi d. After simplification, it gives us d by 4. So hydraulic radius means diameter by 4. Okay. So within this Hagen-Williams formula, this R denotes the hydraulic radius, which is nothing but, we just saw, it is the diameter by 4, right? Now, if we just simplify the pi d square by 4 equals to q by v, if we just simplify this one, then what we will get, this 4 will come, sorry, not this one, we have to simplify in terms of the cross sectional area. So a equals to pi d square by 4, so this 4 will come at the left hand side, 4a equals to pi d square by 4, or 4a by pi equals to d square, or d equals to root over 4a by pi, or 2 into root over a by pi. So the value of d we just have put here, 2 into root over a by pi, and divided by 4 remains as usual. Hope I am able to clarify this. So hydraulic radius r becomes d by 4 equals to root over a by pi whole divided by 2. 2 by 4 means 1 by 2. After putting the value of a that we just have calculated, 0.9375 here, and this pi is a constant, root over root under of that thing whole divided by 2 gives us 0.27314 meter. This is the hydraulic radius. Now substituting this value of hydraulic radius into the Hagen-Williams formula, and also substituting the value of CH, the hydraulic capacity data, which is given in the question as 130. We have to substitute both these values here in this question, in this equation. So we obtain this 1.5 remains the same, and the right hand side becomes 0.85 into 130 into 0.27314 whole to the power of 0.63 into s to the power 0.54. From here we have to calculate the value of s. So s to the power 0.54 equals to 1.5 divided by this entire thing. So 0.85 into 130 gives us 110.5 into this to the power 0.63 gives us 0.4415. After multiplication and after dividing 1.5 with that multiplied value, we get 0.031. Now, slope of the energy line or the hydraulic gradient, which is asked in the question, is S equals to this value we just have calculated whole to the power 1 by 0.54 equals to 0.00158, which is approximately equal to 0.0016. Now in the question, what has happened? This 0.0016 is given as 0.0016%, which is wrong. So all these four options are given as the percentage. So it is not percentage. If we just convert this into percentage, then it becomes 0.16. So which is makes the option C as the correct answer that was given in the question last week, question number 8. If you have solved this one, so but it percentage is not the correct thing. So if we just eliminate the percentage, then 0.0016 will be the answer. So option A will be the correct answer. As the percentage are given, so either everybody will be given marks or nobody will given marks because of this confusion. Okay, so now we'll move on to our next MCQ that you have to answer. Which one of the following is the definition of suction lift? Option A is the difference between point discharge and the pump. Option B is work done by a pump in raising the water. Option C is difference between low water level and pump. And option D is friction loss in pipe. So I'll wait for 1 minute. You can answer in the, you can type your answer in the chat box. What is the definition of suction lift? Surekha, I remember you have attended earlier classes. So Boo Boo, it is your first class, right? I hope you have watched the recordings or you have gone through the slides. Those are uploaded. Okay. So I'll move on with the answer. So difference between the low water level and the pump. Low water level at the suction side, basically. That is called as the suction lift. It is the definition of the suction lift. Yeah. Option C is the correct answer. Now we'll move on to our next MCQ. So there is a picture. You observe the picture very carefully. Now the question is, in the following figure, which type of joint has been used for the water pipes? Can you answer the without any options? Welcome, Oruna. Whatever we have discussed till now, the slides will be available. You can access from there. So the options are A is flanged, B is socket, C is screwed, and D is welded. What type of joint it is for the water pipes? Please, everyone, type the answer in the chat box. Okay. Bubu is telling us welded. Surekha and Oruna. I'll wait for 1 minute before I explain. Okay, so I'll proceed with the explanation. So the answer is the socket joint, not welded. So to clarify, what are the other types of joints? We will just see. So here in this picture, we cannot see any welding. How the welding looks like? It is something like this. So the big things, these circular things, these are called as the flanged. Okay, it may be welded or it may be just casted. Now, how the flanged are joined? They are joined by with the help of the screws. So the screws were also absent in our previous question. So it was your socket joint. And flange joint, welded joint, and screws joint looks something like this. So basically, the middle one is also screwed and welded simultaneously. Okay. And right hand side is basically casted and screwed, and left hand side it is flanged. Now we will move on to our next MCQ. In a water treatment plant, to which unit does water moves from the flocculation basin? Option A is plain sedimentation, option B is clean water tank, option C is settling basin, and option D is pure water basin. Yeah. So you can type your answer in the chat box. Deepti Rani has rejoined. Welcome. All of you type your answer in the chat box. Type the option. So if you are having any doubt while discussing, you can also ask. So in a water treatment plant, from the flocculation basin, water moves to which unit? Okay, D or C? Maybe you are telling us C, right? Yeah. Other three, Surekha, Dipti, and Oruna. You are not answering. Flocculation means what? Flocculation means where flock formations occur. So there are there are charged particles. So the pollutant colloids that is present in the water, with the help of charge separation, they are in suspended form. So if we add some coagulant or flocculant chemical in the water, so they will neutralize those charges and the smaller particles will join together forming big flocks. So once big flocks are formed, then naturally what needs to be done? That is the question. So the answer is the settling basin. C is the correct answer, because after the bigger particles are formed, that is the flocks are formed, then we need the settling, we need to send the water into a settling basin so that the bigger pollutant particles, those are the flocks, they by with the help of gravity, they settles down at the bottom of the settling tank, right? So option C is the correct answer. Now we'll move on to our next MCQ. Which one of the following is not an inferential water meter? A is single jet meter, B is multi jet meter, C is rotary piston meter, and D is voltman meter or voltman meter. So we will wait for 1 minute. Please type your answer in the chat box, the correct option, all of you. It is just a memory based question, so there is no concept involved. If you just remember what sir has taught in his lecture, you will be able to answer. Okay, so I'll move on to our answer of this question. The explanation is something like this: rotary piston meter is a volumetric meter. So volumetric meter means the inferential water meter, so that's why it is an inferential water meter. The other are not inferential water meter. So it's just a memory based question. It's okay if already you don't remember that. So through practice you will be able to remember. I hope you know what is basically a rotameter. Rotary piston meter means rotameter, where there is yeah, sorry, it's not a inferential meter, so it is a volumetric meter. The others are the inferential meters. So I hope how rotameter works. You know, there is a pop which actually floats, and the water flows through the pipe, and there is a drag velocity which is sometimes called as the settling velocity. If the water flows, and with more flow rate, the bob goes up. So in this way, the rotameter works, and if you it gives you the volumetric flow rate. The rotary piston gives you ultimately the volumetric flow rate. It is not an inferential water meter. The other three are inferential. Okay. Now we will move on to our next MCQ. Which one of the following is the correct sequence of treatment units for highly polluted surface water? Option A is pre-chlorination, then aeration, then flocculation, then sedimentation. After the rapid filtration, then disinfection. Option B is rapid mixing, then flocculation, then rapid filtration, then disinfection. Option C is sedimentation, slow filtration, disinfection. Option D is aeration, then flocculation, then sedimentation, then rapid filtration. After that, disinfection. So which one of the four is the correct sequence of treatment of highly polluted surface water? So here we can use a hint, that is where the maximum number of steps will be involved, that will be able to treat highly polluted surface water, right? So option C naturally gets cancelled out. Option B is also very rare that it will be the correct answer. It will be either option A or option D. Okay. So here Bubu has correctly answered. It is pre-chlorination, then aeration, then flocculation, then sedimentation, after the rapid filtration and disinfection. So now here we can see if we just directly throw this polluted water into aeration basin, what will happen? The bacteria or microbes, those are present in the aerobic bacteria, those are present in the aeration tank for the treatment of water, they may get affected. Their population may die. Right. So that's why pre-chlorination must be done to remove the harmful bacteria, to remove the microbes, those are harmful to the bacteria of the aeration basin. After that, the polluted surface water can be transferred to the aeration basin. Rest of the things are same. Right. Okay. Now we'll move on to our next MCQ. Flanged joint is preferred in gas pipelines and can withstand dash. You have to fill in the blanks. Option A is main corrosion, option B is temporary vibration, option C is submain vibration, option D is main vibration. So what flange joint can't withstand? Is it corrosion or vibration that you have to determine? And then where the flange joint is preferred? Is it in main, temporary or submain? What kind of pipelines the flange joint is preferred? That you have to answer. We'll wait for 1 minute. Please type your answer in the chat box. Except Bubu, nobody is answering. Surekha, Aruna, and Dipti are not answering. Why? You just take a guess. Don't shy away. This is no. This session is not evaluated. It is just for practice. You came here for practicing, right? Okay. So the explanation is flange joints are preferred in the temporary pipelines and cannot withstand vibrations. So option B is the correct answer. Okay. So flange joints can withstand corrosion. It depends on the material of construction. If there are different SS grades, that is the stainless steel grades like SS316 and SS 400 or something. So these different grades are there. There are also cast irons, CI or cast steel, CS. Different kinds of materials of constructions are there. If we just handling one kind of corrosive fluid, let's say sulfuric acid, we can use MOC, that is a material construction for construction of the flanges that is resistant for the corrosive fluid. For example, carbon steel, we can use that to prevent the corrosion. So basically, vibration is the correct answer. That eliminates our option 1. The other the things are B, C, and D. So why that is main? Because as flange joint can withstand vibrations, there is the highest vibration in the main pipelines. From the main, the submain pipelines comes out, and from the submain, the temporary pipelines. Sorry, yes, from the submains, the temporary pipelines comes out. Right now, in the temporary in the main, you see the cross sectional area is very high, and these temporary pipelines or submains pipeline, the cross sectional area is very low. So basically, if the fluid same amount of fluid flows through all of them, if the cross-sectional area is low, the velocity will be higher in case of temporary or submarine, right? As compared to main. Temporary, in case of temporary, it will be highest. So that's why. But in case of main and submain, the vibrations will be very high, and flange joint can withstand the vibrations because large amount of fluid flows through the main as it gets divided into submains and further gets divided into temporary. Then what happens? The amount of fluid that flows through submain and temporary are lower as compared to the main. As we saw earlier, that V velocity equals to Q by A. So as the Q increases, the V velocity increases, leading to higher vibrations. So as in temporary pipelines, the vibrations are not that much. So option B is the correct answer. And also another thing is that the main pipelines, it is installed and it is not frequently changed, right? So that's why it is better to go for completely welded thing. If there is requirement for removal of the pipes at a frequent basis, then we have to unscrew the pipelines, right? So that's why the flange joints are preferred there. Preferred in case of temporary as compared to submains or mains. So now we'll move on to our next MCQ. Which one of the following factors do not influence plane sedimentation? Option A is viscosity, density, and temperature of water. Option B is detention period. Option C is changes in shape, size, or weight of particles during settling. And option D is effective depth of settling zone. It is also a memory based question. Three factors influence plane sedimentation. What are the three factors and which factor don't influence? That you have to identify. For grit removal, we have solved one problem in the earlier classes. If you just remember that problem, and also we have shown how grit chamber works. So the sedimentation is not the completely same, but it also works in a similar way. If you just remember that picture, then I hope you will be able to answer. Otherwise, if you just have watched the lecture, then also you'll be able to answer. So we'll move on to the solution, I guess. The answer is the changes in shape, size, and weight of the particles during settling. This is the factor that do not influence plane sedimentation. But if it is not the plane sedimentation, then it will influence. Okay. Now we will move on to our next MCQ. Which one of the following is not considered while deciding the land available for the design of the distribution networks? Option A is sizing of water pipes. Option B is water distribution systems. Option C is water treatment units. And option D is water reservoir locations. While designing of the distribution network, which one of the following factors is not considered? While deciding the available land. Uh, okay. So the answer is sizing of the water pipes. You can see water distribution system is related to the distribution network. Water treatment units, because different tanks will be there in the water treatment units, like the flocculation tank, sedimentation tank, the settling basin, the aeration tank, pre-chlorination tank, and also disinfection tank. So the sizing is are required. So it will be considered because it takes the tanks take significant available lands, and also the water reservoirs before and after the treatment. It also takes significant lands. But sizing of water pipes doesn't take it takes space definitely, but in terms of the lands available, it doesn't take much space. So that's why it is not considered while deciding the land available for the design of the distribution networks. What happens if there is a yeah? So if there is a let's say rack of the pipe racks, then you are designing you are let's say enhancing the capacity of a treatment plant, then definitely the sizing of the water pipes will come into the picture, because you are having a existing pipe rack which is having a existing defined capacity, limited capacity for the fluid to carry, for the water to carry through the pipe racks. So the pipe racks have a limited ability to withstand the weight of the heavy pipes that is flowing through the pipe racks, right? So if you just want to increase the capacity of the water treatment plant, then sizing of the water pipes will definitely be considered. But at the preliminary design of the distribution network, which is the major design in our case, sizing of the pipes are not considered while deciding the land availability. Okay, so now we'll move on to our next MSQ. So it is a multiple select question. More than one options may or may not be correct. So whatever we have seen till now, those are all multiple choice questions. So only one option were correct. But in this question, multiple option may or may not be correct. Maybe one option correct also. So the rate of the exchange of gas in the process of water purification depends on which one of the following factors. Which of the following factors? One or two factors. So P option P is area of the interface between gas and liquid. Option Q is partial pressure of the gas. Option R is compression depth of air, and option S is time of contact. The rate of the exchange of gas in the process of water purification depends on which one of the following factors. Which of the following factors? Uh, Rate of gas exchange that you can think about. So let's say let's assume a absorber column where the gas is being absorbed in a liquid. Let's say. So what factors will affect the rate of the exchange of gas? Let's say carbon dioxide is getting absorbed into water, right? Yeah. So which gives you the carbonic acid, or maybe carbonic acid has come into the water, has made it acidic. You want to strip it out. So you want to remove the carbon dioxide, dissolved carbon dioxide from the water in order to treat it. You have maybe you are having a degasser column. So within the degasser column, what are the factors that may influence the exchange process? So time of contact will definitely, I guess, will be a factor that will influence. So the more time the more time the acidic water spent in the column, the more stripping operation will happen, right? Time of contact should affect area of the interface between gas and liquid. Yeah, option P, as Surekha has told, it should definitely affect, right? Let's see what are the other factors. So the explanation is something like this. The rate of gaseous exchange depend on the interfacial areas between gas and the liquids, as Sugareka correctly pointed out. Thickness of the interlayers, contact times, as I told, and then what else? The partial pressure of the gas and the degree of undersaturation and or oversaturation of the gas. So option Q is also another correct answer. So option P, Q, and S are the correct answers. Partial pressure of gas. If any one of you are from chemical engineering background, then you know that the gaseous exchange process essentially calls a mass transfer process, and in the mass transfer process, partial pressure of the gas is a major factor. So that's why option Q comes into the picture. But compression depth of the air, it has nothing to do with the exchange of gas for water purification. Okay, so option P, Q, and S are correct answers. Now we'll move on to our next MCQ. Which one of the following statements is true for the looped system of pipe network design? Option A is entering and leaving flow is discontinued. Option B is the quantity of water entering and leaving the pipe junctions are not equal. Option C is law of continuity must be satisfied. And option D, discharge and flow direction always remains the same with the change in demand. I'll wait for 2 minutes. This problem, you have to think a bit. You can see what I feel is that option D, I don't think it can be correct because uh, flow direction may remain the same, but discharge capacity will not remain the same. If the demand increases, discharge will increase, I guess. Yeah. Entering and leaving flow is discontinued. I don't think also it can be a one correct answer. I don't think because uh, the entire flow is continuous in water treatment, in be it a upstream water treatment plant or be it a downstream water treatment plant. So all these cases, the flows are continuous. Even if in batch process it is continuous. So batch process doesn't mean continuous, but flow is not discontinued in that sense. Yeah. So maybe option B and C, anyone must be correct. Surekha is telling us option C. We'll see what is the correct answer. So yeah, you have identified it correctly. Law of continuity must be satisfied. Law of continuity means what? Area into velocity must be remain constant. A1 into V1 equals to A2 into V2, which is nothing but the conservation principle of mass. So as the temperature is not varying much, so that's why we are assuming constant density of water. That means the volumetric flow rate remains the constant. That is nothing but the law of continuity. It must be satisfied. And option B, the quantity of water entering and leaving the pipe junctions are not equal. It is not also correct because what is the case when it will not be equal? When there is leakage, and we cannot consider it to be a good design where or good maintenance where that leakage is there. So leakage ideally must not be there. Okay, so option B cannot be also the correct answer. Option C is the correct answer. Yeah. So now we will move on to our next MCQ. Which one of the following treatment? It is also a single correct answer question because it is not MSQ, it is MCQ. Which one of the following treatment methods is primarily used to remove pathogenic bacteria in the water treatment plants? Option A, disinfection. Option B, hardness removal. Option C, filtration. Option D, aeration. It is pretty easy question. All of you should answer. Yes, Bubu has also answered the previous question. C was the correct answer. So all of you should answer this. Deepti and Aruna also. It is very easy question. Which one of the following treatment method is primarily used to remove pathogenic bacteria in the water treatment plants? Which one is associated with removing bacteria? Disinfection, hardness removal, filtration, and aeration. Bubu is telling us D. See, the D aeration, I'll start from the last one only. Aeration tank, generally the bacteria those are present in the aeration tank, and you two are telling us C, filtration. Okay, I'll explain them. So aeration tank, the bacteria and present, mainly those are taken from cow dung. So those bacteria and viruses help in reducing the BOD. BOD is called as a biological oxygen demand of the water. They are used to reduce the BOD content of the water. In later classes, we will solve couple of problems of BOD, then it will be easier for you to understand. So now aeration reduces the BOD. It doesn't reduce the pathogenic bacteria. Okay. Now filtration. What is filtration? So we'll see the answer first. So disinfection is the correct answer because see the infectious disease you have seen, right? So pathogen causes infection. So the opposite of infection is called as the disinfection. You either do it with the help of chlorine, you may do it with the help of ozone, or you may do an UV disinfection, that is called as the ultraviolet disinfection. But the ultraviolet ray damages the DNA material of the bacteria or viruses, that is the or the pathogens that is present in the water. So the bacteria those are present in the aeration tank, those are beneficial for the reducing the BOD. We should not kill those bacteria. If we kill those, the aeration tank will not work. So the aeration process, already inherent bacteria present is there, and we are not removing them. Hardness removal is related with something else, that is removing the bivalent ions. Those are calcium or magnesium ions. Those are present in the water. So hardness removal is related to that thing. If you keep the water in a stagnant condition, you will see after some days or after some weeks, the white there is a white layer at the inside of the utensils within which you have kept the water. So which is an indication of the non-removed hardness that is present inside the water. That is related with the hardness valve. Filtration is related with removal of the large particles like leaves, dust, bigger dust particles, which is visibly present inside the water. Aeration, as I told. So all of the three options are not correct. Option A, disinfection, is the correct answer in this case. So now we'll move on to our next MCQ. In the process of hydraulic network balancing, distribution of the pipe flows and pipe dash are balanced. So pipe flow is balanced with what? Pipe profile, pipe depth, pipe outgrowth, or pipe head losses. That you have to identify. Okay, so I guess as the time is almost up, this is the last question that we are going to discuss. The other things we'll discuss in the next class. So yes, has anybody answered it? Okay, Bubu is telling us option D, head loss. Dipti is telling us option B, depth. For hydraulic network balancing, what do you have to balance? So whenever you are designing one pump means what? Then two things we have to majorly consider. One is the flow rate, that is the volumetric flow rate in meter cube per second unit, and another one is the head loss. Head loss is basically the pressure drop that is expressed in the terms of the Bernoulli's equation, where you divide P with rho g. P is the pressure, rho is the density, g is the gravitational constant, 9.81 meter per second square. So if you multiply rho with g and you divide P with that, then you get the head loss. That is the option D. Okay. So let's see. That was true in case of pump. Now in case of pipe, what is true? In case of pipe also, option D is true, because outgrowth is not nothing related to design, where you have to uh, In case of, that's right, yeah. So in case of design, you will run the plan in such a way you will disinfect the water, and you will also use the UV or other disinfection procedure like your ozone or chlorine treatments in order to stop the outgrowth. So you will not design the plant considering the outgrowth, right? And the depth and profile are also not true. The pump design is directly related with the pipe design. And in case of hydraulic network balancing, you consider these two factors only. One is the volumetric flow rate, and another one is the head loss. So option D is the correct answer. Okay, who has answered it correctly? Now I think the time is up, so we can stop here. The other things we can discuss in the next class. We will rejoin on 7th September. So most of you joined at the second half. That is from 8 p.m. onwards. So the session starts at 7 p.m. 7 to 9 p.m. So anyways, the recording will be uploaded, and also the slides will be uploaded in the Google Drive. The links are shared, and hope you will watch the recording, or you will go through the slides for the problems that you have missed. Okay. So okay, yeah, bye bye. We'll meet on September 7th, 7 p.m. Okay. Good night, everyone. Yeah, I'll stop the recording and I will end the session.